In this video, we're going to look at how to determine if we have a set of data, whether it's a logarithmic model. First of all, we need to look at what a logarithmic model would look like as far as a function. And this would be an example of an equation of a logarithmic function. So there are three different constants in this logarithmic function. We have a little a b that's multiplied by the log function, and then the base c. Now, how do we look at a set of data and determine whether the function itself looks like it's logarithmic? Well, remember, a log function is going to end up being the inverse of an exponential function. In an exponential function, as the independent variable changes by a constant amount, the dependent variable changed by a constant factor. So since a logarithmic function is going to be the inverse of an exponential, we're going to have the variables have opposite characteristics. Here's an example of a logarithmic function. I have my independent variable x, my dependent variable y, and as the independent variable is changing by a factor of 10, I have my dependent variable finding these constant differences. My dependent variable is increasing by 3. So that's the characteristic for logarithmic. So as independent variable changes by a constant factor, the dependent variable is changing by a constant amount, which is just the inverse of what an exponential function does. So there are a couple different ways to find the answer for the model. One way is once we figure out that we have this characteristic, we look at the model and we set up a little system of equations. And now in the previous models that we had, if we had 3 unknowns, we would have to get a system of 3 equations. However, actually in the logarithmic modeling, we have one little factor that makes it a little easier for us. We can actually choose what base our logarithm will be written in. I usually look at my values. I see that my values are having a factor change of times 10, so it would actually be very convenient for me to have this written in terms of logarithm base 10, or as a common log. So I'm choosing to use c being 10. You could also find this model by having this be a base e as a natural log. You could have this be 2. You could have it be any base you choose. That is some base that's greater than 1. Now, once I had established that I'm going to choose base 10 for my letter c, then I only need a system of 2 equations. And so I need 2 points, and I chose to use 2 of the points that are the first 2 points. I could have chosen to use the third and fourth point. So any 2 points that I choose will fit the pattern and help me find my model. I'm not going to go through all the steps, but I solved my system, and I found out that if I choose c to be the base of choice for my specific logarithmic equation, that it ends up the coefficient b in front came out to be a 3, and my a factor came out to be a 2. And you can follow my steps and try it on your own to get that model. So now I have this model. The nice thing about this is I can check this because base 10 is on my calculator, or I can calculate what these values are to double check them. For instance, say I take this last point. If I take 1,000, plug it in place of x, I know that the log of 1,000 in base 10 is 3. 3 times 3 will be 9, plus 2 will give me 11, and I can see that that point checks. It's always nice to check one of the latter points, particularly one that you didn't use to find your system of equations, to make sure it works. And I could check other points as well. Now, I said there was more than one way to find that logarithmic model. So using a system of equations with the logarithmic equation directly in this form is one way to find the system of equations, or the simplification for that model. Now, the alternate way is to realize that, hey, I already learned how to find models that were exponential. And so is it possible that I just reverse these and make the table of values look like this, and see that as my independent variable, if I chose to switch these variables around and have the y value be the input variable, that as the independent variable changes by a constant amount of 3, the dependent variable changes by a constant factor of 10. Could I find an exponential model that would fit this pattern and then go back and just solve the equation for y? Yes, you may do that. Your model will look probably a little bit different, however, algebraically it will be equivalent. We've gone through how to make exponential models before, so I'm not going to go through the technique of that, but that is definitely a way for you to solve and find what the answer is for the logarithmic model. Don't leave it in the exponential form, because the data itself was given at the very beginning as the input variable being x and the output variable being y. So I expect to see the function finally written in a form that will be logarithmic in nature. However, you could find the model with the exponential type of analysis and then solve the equation for the y variable. And that finishes the video for now.